Morning, afternoon, for everybody watching. Welcome back once again to the Mickey Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. Come along, we have something very interesting. A question that borders on probability. It says if two fair coins are flipped. So when I flip two coins, one fair means that the outcomes is not predetermined. That's why I say fair dice. The possibility of them landing either head or tail, it's not something that is controlled. So you can either land on the head or the tail. Now, I flipped. What is the probability of getting at least one head? Because a coin has two parts, the head and the tail. Now, the first thing we do, we work out our sample space. So if I throw two coins, so the first, I can either have a head or a tail. Then from here, when I throw it again, I can either have head or tail, or from here, head or the tail. So in two throws, if the two coins are thrown, this is the possibility of the outcome. It's either I have, for the first one, I have a head, and for the second coin, I have another head. That means two of them land on the head at the same time. When I throw them, the two of them land on the head. Or I can have the first one land on the head and the other one land on the tail. That's a possibility. The first coin land on the head, the second one land on the tail. Now, or I can have the first one land on the tail and the second one land on the head. And the last possible outcome I can have is the two of them landing on the tail. So this is the sample space, or the probability of what I can get when I flip two coins. Now, look at the question. It says, what is the probability of getting at least one head? That means in all this, at least one head. In this place, look at it. I have one head here. One. Then, in this other place, I have one head here. The sample space is 4. 1, 2, 3, 4. 4 possible outcomes I can have. Now, probability of getting at least a head will be, where do we have head? 1, 2, 3. So this is 3. So the probability of one head at least will be equals to, how many places did you see head? 1, 2, 3. 3 out of what are the outcomes that I could get when I flip the two coins? 1, 2, 3, 4. 4. So that's 3 over 4. Now the next one says, if there are 3 coins are flipped, what's the probability of getting at least 2 tails? If 3 coins are flipped, this is what we will have. 3 coins are flipped. So we have, I will extend this. So here I can have head, tail, head, tail, head, tail, and head, tail. So if 3 coins are flipped, it's either I can have head, head, head. That's the first one will be land on the head. The second one will land on the head. The third one will land on the head. That's the first outcome. The second one, I can either have head, tail, or head. That means the second coin lands on the tail, while the other two lands on the head. So head, tail, head. Now, either I have head, tail, tail. Head, tail, tail. Head, tail, tail. Now, or I can have the first one land on the tail, tail, head, head. Or tail, head, head. Or I have tail, head, tail. Tail, head, tail. Tail, head, tail. Or I can have tail, tail, head. Tail, tail, head. And the last possible outcome, tail, tail, tail. Tail, tail, tail. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, I've omitted one. Head, head, head. 1. Head, head, tail. Okay, that's the one I omitted. Head, head, tail. Okay, let me put it there. Head, head, tail. Now, how do you know? Because there are 3. You use this formula 2 to the power of 3. So there will be 8 possible outcomes. That's how I knew that I made a mistake, or there was one that I didn't pick out. Now, this is the possible outcomes. Now they ask us that what's the probability of getting at least 2 tails? Now, where do we have 2 tails here? This one, there's no tail here, so we discard it. Here we only have 1 tail. It doesn't qualify to what we are asking for, at least 2 tails. Now here I have 1, there's 2 tail here, so 1. Said I can get this head, tail, tail. Now look at this other one, tail, head, head. No, only 1 tail, so I can't use it. Look at this tail, head, tail, 2. Now the third one, 3, and this one there's at least 2. You know, say if there can be more than 3, there can be more than 2. So this is also qualifies. So how many do we have that qualifies to that? For that, 1, 2, 3, 4. So probability of getting at least 2 tails will be equals to the required outcome. That's the required outcome. That's the ones that have tail, tail, tail. They are 4. So that's 4 out of the total possible number of outcomes. How many outcomes can we have? 8 possible outcomes. So 4 over 8, which is equals to 1 over 2, which is the same thing as 0.5. So the probability of having at least 2 tails is half. I hope you have enjoyed today's class. If you enjoyed today's class, why not give us a like, give us a share, tell your friends about the Making Maths class, a channel so dedicated to demystifying mathematics, making complex problems look easy. If there's any question that you don't understand, put in the comment section. I'll be there to attend. Or any aspect of mathematics you are struggling with, put it. I'll be there to attend to you. If you're yet to subscribe, please kindly hit the subscribe button. Turn on the notification bell so you don't miss out from wonderful content on the channel. Till meet again in the next Making Maths class. Keep practicing. Remember, mathematics is fun. See you at the top. Shalom.